Today, got a big shout out to Jay Gel. Optional Thursday going on here. He lost a bet. He's wearing an Iowa shirt. Nobody wears an Iowa shirt. I got an Iowa shirt at home. I used to pick up dog poop in the backyard. That's how I feel about that. Here we roll. All right. So, a couple examples to get through today. You're going to have a lot of time to work on your assignment. But some of you have seen simplifying rational expressions before, and some of you have not seen them. But as long as we have the skill of factoring, it's not going to be that difficult for us to master. So, we're going to look at this example right here, where we start to multiply. Yesterday, we looked at just a couple examples of simplifying. Today, we look to multiply. And I'm going to do this two ways so that I can try to make a point here. So we're going to be... Oh, sorry, guys. So if I multiply straight across, I get 12x over 18x. After I multiply, I could then choose to simplify. 12 and 18 simplifies to what? 2 over 3, and the x's cancel, so the result is 2 over 3. But I want to be clear that if things are written in factored form, you don't have to multiply them first. Instead, you can look to cancel things out. For example, look at the 3 over 9. What will 3 over 9 reduce to? 1 over 3. So those are gone. 4x over 2x, what do those reduce to? 2 over 1. So now multiply that and get 2 over 3. So see your two options for simplifying? Look at the next one. I don't want to multiply that all out. I want to look to see if something will cancel. What's going to cancel? X plus 2 cancels x plus 2. Hey, does 4 over 12 cancel? Simplify? What do I get? So I get 1 over 3 times x minus 1 over 1. So it's x minus 1 in the numerator. So I get x minus 1 over 3. Sometimes it's not written in simplified form. It's not written in factored form, I should say. The next one, x plus 5, does not factor. And 3x plus 1 does not factor. However, what can you factor out of 3x plus or 9x plus 3? You factor out 3. When I factor out 3, what am I left with? 3x plus 1. Then the denominator, x squared minus 25, how does that factor? X plus 5, x minus 5. Difference of 2 squares. Great, I've got it. I'm going to look to see what cancels. Sure enough, the 3x plus 1s go away. What else cancels? And you can see what I'm left with is 3 over x minus 5. So you can see when we're simplifying rational expressions, the key is to make sure that you can factor. The next one, x squared plus 2x minus 3. What does that factor to? X plus 3, x minus 1, x squared minus x minus 2. Factors to x minus 2 and x plus 1. Now, I'm going to write the x plus 3 in the denominator, but I'm not going to write the 2 minus x in the numerator. So I want you to see something. 2 minus x is similar to something up here, but it's not the same. What is it similar to? X minus 2, but they're not the same, are they? If you notice here, the x is positive, but here the x is negative. Here the 2 is negative, but here it's positive. What could I factor out so that they would be the same? A negative 1, if we factor a negative 1 out of 2 minus x, the x becomes positive, and the 2 becomes negative. So factor on negative 1 is a nice trick. What cancels? 3's minus 2's. So I have negative 1 times x minus 1 over x plus 1. Last section to check out. Raise your hand if you really don't like division that much. Okay, only a few of us. A lot of you guys love division. It's cool to like division. That's all right, you know, good for you. I don't really like it, so I choose to never divide. Instead, what do? Multiply by the reciprocal. So you can see if you ever see dividing, we do the same thing we did in the previous problem. We just rewrite it as 2x over 3 times 12 over 6x squared. Now we can look across and look to cancel. 12 over 3 reduces to 4 over 1. 2x over 6x squared reduces to 1 over 3x. Leaves me with 4 over 3x. Sometimes instead of rewriting everything, what I do is I just take this second part here. So instead of dividing, I'm going to multiply by the reciprocal. X times x plus 1 over x minus 2. So I just cross that off, get rid of it. So now I've saved myself a little bit of time. You can see what obviously cancels. The x plus 1s are gone. The x minus 2s are gone. There's nothing left in the denominator. I simply have x times x plus 2 in the numerator. I want you to try letter C on your own. Try letter C. Good time. Good times. All right, let's see what you got. You're supposed to try this one on your own. You got x squared minus 1 over x plus 3 times x squared minus 9 over x plus 1. Hopefully you saw this difference of two squares. X plus 1, x minus 1 over x plus 3 times x minus 3 times x plus 3 over x plus 1. We can see what cancels. We got the plus 3's. We got the plus 1's. We got x minus 1 times x minus 3. Now the last one, a little bit more challenging. I'll multiply by the reciprocal, which is 2 minus x over 3x plus 3. So I get rid of that guy. I look at x squared plus 4x plus 3. How does that factor? X plus 3, x plus 1 over, it's like x plus 4 times x minus 2. Now, should we factor the top? Should we factor the top? Yeah. What do we factor out of the top? A negative 1. And when you do, you get x minus 2. What do you factor out of the bottom? The 3, you get x plus 1. So, start canceling. This is people's favorite part. X minus 2's go away. X plus 1's go away. On the top, a negative x plus 3. What do you have on the bottom? Good. A lot of people miss the 3 and just write x plus 4. You got the 3 stand there as well. So that's our final result. Okay? So this is the basic introduction to simplifying rational expressions.